Okay, so today we are doing synthetic division. This one you can only use when your factor that you're dividing by is a linear term, so like x plus 3, x minus 3. If you have like quadratic or higher, you have to use long division. And then I'll just work through it to show you. So when I'm doing synthetic division, we have what kind of looks like a giant L. Did I say long? I meant synthetic. Okay. Then what I want to do is I want to write all of my coefficients of my dividend on the inside. I have, notice when I look at this, I don't have an x cubed term. So I'm going to have 0x cubed as my placeholder. So then when I write my coefficients, I have 1 for the x to the 4th, 0 for my x cubed, negative 10 for my x squared, negative 2 for my x, and then 4 for my constant. All of those numbers just came from my coefficients right here. Okay. Then for my number that goes on the outside, I always want to take this x plus 3 part and set it equal to 0. Which gets me x equals negative 3. So that's the number I'm going to write outside here. Okay, then what I do is I drop down my first number. And then I always take the number that's down here and multiply it by my number on the outside. So I have 1 times negative 3 gives me negative 3. And then I always add down. So I'm going to take 0 minus 3, which is negative 3. Then I'm going to take this negative 3 and multiply by this negative 3 out here, which gives me positive 9. Okay. And then I add down negative 10 plus negative, or positive 9 is negative 1. Then I take the negative 1 and multiply by the negative 3, which gives me positive 3. Then I add down, so I have negative 2 plus 3, which gives me 1. And then I'm going to take the 1 times the negative 3, which gives me negative 3. Then 4 minus 3 is 1. Then what I want to do once I have these numbers is I want to put back with variables, and I start with 1 degree less. Okay, so what I'm going to do is my highest exponent originally was x to the 4th. So I'm going to add this 1 in front of x cubed, because that's 1 less. I don't need to write the 1 for x cubed, so I'm just going to write x cubed. Then my next term is going to be negative 3x squared. I just count down with all of my exponents. My next term is going to be negative x. Negative x. Then I have a positive 1, which is just a constant here. And notice I have an extra number. This number is going to be my remainder. So I'm going to have the 1, and then it always goes on top of what I originally was dividing by, which is x plus 3. And then this is my final answer. Are there any questions here? Okay, so for this next one, we can also use synthetic division to evaluate for a specific number. This is called the remainder theorem. The remainder is just our answer to the problem. So what we do is we set it up very similarly. I am going to write all of my coefficients from my original polynomial. So I have 3, 8, 5, and negative 7. And then it's giving me a specific value to evaluate. So I already have it set equal to negative 2. That is my number on the outside. Okay. Then, just like before, I'm going to bring down my first number. And then I want to multiply by that negative 2. So 3 times negative 2 is... Then I want to add down. So 8 minus 6 is... And then 2 times negative 2 is... And then I add down. So 5 minus 4 is... Okay. 1 times negative 2. And then negative 7 minus 2. Negative 9. So my answer here is just the remainder. It's the negative 9. So questions on this method, or this type of question? Okay, so the last thing we have is the factor theorem. It means if I get a remainder of 0, that it is a factor of that polynomial. Number 5 wants me to show that x minus 2 and x plus 3 are factors of this polynomial. So what I want to do is I'm going to first set these both equal to 0. So I get x equals 2. And x equals negative 3. So then I want to set this up for synthetic division. I'm going to start off with my 2, and then I'm going to write all of my coefficients. All of my terms are here, so I don't need to worry about any placeholders. Then, just like before, I want to bring this number down, and then multiply. 2 times 2 is 7 plus 4 is 11 times 2 is 22. Negative 4 plus 22, 18. 18 times 2, 36, or negative 27 plus 36, 9. And then 2 times 9, 18. So my remainder here is 0, which is good news. That means 2 is a factor, or x minus 2 is a factor. Then I can keep checking, and I'm going to use my negative 3, and I'm going to go ahead and use the numbers I got from my first answer. So I'm going to use 2, 11, 18, and 9. So then, same thing, I'm going to bring down this 2. 2 times negative 3 is, what? Negative 6. 11 minus 6 is 5 times negative 3. Negative 15. 18 minus 15. 3. 3 times negative 3. Negative 9. 9 minus 9. 0. So again, I got 0 as a remainder, so that means that is a factor. This question wants me to keep factoring once I prove that they're factors. So what I'm going to do is I'm going to turn this back into a polynomial. So when I went down to here, I went to cubes, because my original was x to the 4th. Then when I go down to here, I'm going to have squareds. So I have 2x squared plus 5x plus 3. When I put back in my variables. And then I want to factor this, so I am going to look for my a and c values. A is 2, c is 3. So then I want to do AC, which is 2 times 3, which is 6. So I'm looking for two numbers that multiply to 6 and add to 5. 2 and 3. 1 and 6 don't add to 5. Okay. So then I want to split up my middle term. And then I want to factor by grouping. So what goes into my first group? 2x. 2x squared divided by 2x. X. 2x divided by 2x. 1. In my second group, what can I pull out? And then 3x divided by 3 is plus 1. Okay, so I get my outside parts go together, and then I have my inside parts. And because I'm factoring my original polynomial, I want to add the two factors I knew from before back to it. So this is my final answer. Questions here? So the last two came from right up above.